Greetings, class. I'm going to do a quick review of problem number 4 for your class assignment. This was covered in class before our midterm in week 5, but I want to just make sure everybody understands what we're doing and how to maneuver around in Excel. And I'm also going to compare what Excel is putting out to what we did in our lecture slides. So this is the problem from week 5. We are going to be, as our slides, we're going to be covering the analysis of variance, the one-way ANOVA test. And so what we are going to be comparing are the population means. For the null hypothesis for the analysis of variance is we're comparing population means of more than 2 sets of data, right? And so our alternative hypothesis would be that not all population means are the same. And so back to this, we have 1, 2, 3, 4, 5 populations. And in this case, I guess we can say that, see, there are 5 groups. Our value for C is 5 groups. And our N in this case would be 50 sets of data, right? Is there a difference? The question is there a difference in the mean amount of food eaten among the various products? And so one of the things that you can discuss here are, you need to state your null hypothesis. And it would be a good idea to list your variables. Why? Well, because that way you know what you're working with. I can know what you're working with, but it would be good to know that you know what you're working with. I'm just changing some of this information around. And then that way you can kind of that way you know the difference between what I'm writing and what the directions are. So one of the first things you need to do is come to this button right here, data. You need to have this data analysis button. If you do not know how to do that, Google is going to be your friend, because I've showed how to do this in class several times over. And so you need to download this add-in. So we're going to do the data analysis. We're going to find the ANOVA single factor. That is what because all we're factoring in is the amount of food eaten, the feeding time, and the measured amount of food in ounces in 10-minute intervals. Okay, and so ANOVA single factor, we're going to highlight all of this data here. We're going to click on that, make sure the labels are correct. They're grouped by columns. Notice you can group by rows or columns. In this case, each individual one is a column. And our output range, I don't want a new, I'm just going to put it right in here. And it will give us the information that we need. Okay, and so here we are with our data. And so you will notice, I'm just gonna do a few things here. All of our borders, I'm just gonna highlight all of this right here, or maybe I'll just put it in a border And maybe I will, yeah, that's good. So one thing I want to point out here is, notice they're giving the count for each individual type of food: kidney, shrimp, chicken, liver, salmon, and beef. And they have the sum, the average, and the variance for each individual item. Now, so one thing I want to point out here is, let's pull this up here. Some things I want to compare. Let's pull this to the side. And if we get to compare the SSA, which is this value right here, and the SSW, which is this value right here. This is the among group, or in this case, sum of squares between groups. Excuse me. And then this, the SSW right here is the within group variation. And so each of these values, one of the things I want to point out is that Excel is computing this equation, this SSA equals the sum of n sub j times the mean of j minus the grand mean, or the mean of all data values, and that value squared. And they're taking the sum of all of these things, and in this case giving us our between group variation. In our next slide, it is our SSW. This equation right here is going to spit out this number right here, 1.97. Let's bring that slide back up. And so the SSW, this is the, I keep hitting it, I'm sorry. This is the equation for 1.978. And again, the more that you use Excel, the easier that it gets to use, obviously. And the value that you're actually finding, which is your F value, you're actually taking this MSA, dividing it by the MSW. And so if you pull up your PowerPoint at the same time, you can see that your MSW is just the SSW, which is this guy right here, divided by this value, 45. And our MSA value, which is 0.91474, is just this 3.65 divided by 4. And so how do we get our F ratio? It's actually an F ratio. You can see here, the F ratio is just this number, 0.91474 divided by 0.043966, giving us this value right here. And then you can see the SSA is given by this blue, SSW is given by this green. We have our SST, right, or your total sum of squares. This is our degrees of freedom, which is, we have 5 groups, minus 1 gives us 4. We have 50 samples, and 50 minus our C, which is 5, gives us 45. And our total degrees of freedom, which is 50 samples total, minus 1 gives us 49. Our MSA is really just the SSA value, 3.65 divided by our C minus 1. And our MSW value right here, 0.04, is just your SSW value divided by 45. And so our F ratio is just 0.91474, our MSA, divided by 0.043966, which is our MSW. And that gives us this F ratio. Now, our F critical is determined by the appendix in the back of your book. And you should be able to find that given your degrees of freedom and your alpha value. So that is what I wanted to cover for problem number 4. You can see here interpreting the ANOVA statistic, right? We're going to reject the null hypothesis. So hopefully you've taken the time to determine your null hypothesis here in part A. And then you have some questions to answer. So as you can see, we are going to reject the null hypothesis. There is a difference according to our F statistic and our F critical values in the, there's a difference in the means provided here in our ANOVA single factor. Now, the next step is to construct multiple comparisons to test the null hypothesis that the differences in the means of all pairs in the store locations, in the times are equal to 0. Now there's quite a few different tests, but we are going to talk about the Tukey-Kramer comparison procedure for one-way ANOVA to determine which of the means are slightly different, or significantly different, This procedure enables you to simultaneously make comparisons between all pairs of groups. The procedure consists of 4 steps. We're going to compute the absolute mean difference, which is this guy right here. We're going to compute the absolute difference. And then we're going to compute the critical range, which is this guy right there. And then step 3 is we're going to compare each of the pairs against its corresponding critical range. And then we're going to interpret this result. So here we're going to compare the differences. And so I got this started already. We have our, this is mostly provided for you. We have to do a few things. If you notice, let me see if I can make this a little bit smaller. This value right here is called from this value that was found from our ANOVA. It is our MSW value. And so I'm going to pull up our chapter 11 slides. And so here we can see we're going to reject our null hypothesis. It's a different set of data, but we are also rejecting our null hypothesis. And we have this ANOVA Excel output. And now we're going to do the Tukey-Kramer procedure. We're going to allow pairwise comparisons. And so this critical range here, notice it's our critical value times our MSW divided by 2 times 1 over NJ and 1 over NJ apostrophe, which are basically our sample sizes. And so if we make this a little bit smaller and we compare these values here, we are going to do a few things. We need to find our Q statistic. And so provided in your Moodle page, let's see here what happened. Provided in your Moodle page is a Q table, and provided in your Moodle page is a Q table. So we have 0.05 level of significance according to our spreadsheet here. We have 5 groups and 50 sample size. And so here we are between groups, which will be our numerator, and our within groups, which will be our denominator. So we're going to go back to our student-dies range distribution. So this is our numerator here. And then we're going to go all the way down to 45. So you go across 4, because that's our numerator. and we're going to go to 45. So we have 3.77. So we're going to input that information here. We're going to input this information here. 3.77. There's that information. And now we need to do the absolute difference between our groups. And so if you notice here, this is the absolute difference between from group 1 to group 2. So group 1 minus group 2, and we're doing the absolute value. And so we're going to keep doing that. We're going to do the absolute value of, this case, group 1 minus group 3, and close that out. This is equal to the absolute value. This one says group 1 minus group 4, and close that one out. This one is equal to group 1, oops, it's absolute value, group 1 minus group 5. Okay, so these are our absolute values. We'll keep going, and according to the directions given, group 2 minus group 3, close that one out, equal to the absolute value of group 2 minus group 4, close that out. This is equal to the absolute value of group 2 minus group 5. This is equal to the absolute value of group 3. Oops, what happened here? Is equal to the absolute value of group 3 minus group 4. This is equal to the absolute value of group 3 minus group 5. And the last but not least is the absolute value. We're just subtracting them, if you haven't figured that out yet. Group 4 minus group 5. Okay, and so here are our absolute differences. Now our standard error here, if you notice, is the MSW, the square root of the MSW divided by 2 times 1 over our sample sizes. Now our sample sizes are all the same, and so all we're going to do now is we're going to take this value right here and scroll it all the way down. So that is our standard error. And so now here, notice all we're doing is we're multiplying. Our critical range is our Q value that we found times our standard error. And if you look back at our, it's our Q value, and then this guy right here, the square root of MSW divided by 2 times 1 over the sample sizes, is our standard error. And so back here, this is giving us our critical range. And we're just going to take this value and scroll it all the way down. So notice our critical range is the same, and our standard error should be the same. And so now the results, what's really nice is if you look at this equation, it's an if logical test. If this value right here, our absolute difference, is greater than our critical range, the means are different. If it is not greater, the means are not different. Okay, and so this kind of answers our test for us. And so we're just going to take this value and scroll it down. And so you can see here, let's do a different color for the ones that are different, so you can see. There's quite a few that are different. We're going to highlight those a different color. So there are 3 that are not different and 2 that are different. And you can see here, if you click on it, it's comparing the values, right? And what does this tell you? So if appropriate, which test would you use to determine which products appear to differ significantly in the mean amount of food eaten? And so you can see here that compared to group 1 and group 2, which in this case is kidney and the shrimp, and then group 2 to group 3, so kidney, shrimp, and the chicken liver are not different. Group 1 and group 2, group 1 and group 3, group 2 and group 3, and like none of these are different. And so what conclusions can you draw from this? You need to actually do all of this work. You need to have all of the equations in here. And I will provide a formula sheet. It's going to kind of look like this. This is the turkey Kramer. This is a sample. And here are the sample formulas that I'm going to be providing as well, so you have something to refer to. And so now that you have all of this information, the conclusions that you can draw here are, and I said it before, but the kidney, shrimp, and chicken liver are not significantly different. However, the salmon and beef are. Okay, and so, you know, while we rejected our null hypothesis, so part A, at the significance level, is there a difference in the mean amount of food eaten among the various products? For this one, we do reject our null hypothesis. You are going to have to take the time to write out your null and alternative hypothesis. It would be a good idea to list your variables, and then you need to have this ANOVA single factor results available. Now below, you're going to have this as well, but this will all be empty, 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 and you will have this information available, this information available, and this right here, a Q statistic that you needed to find using this table right here, the studentized range distribution will also be empty. Okay, and but this is how you do problem number 4.